Hey friends, here I am again to teach you about tangent and cotangent. I hope the quiz went well for you. Now let's get started. So, one thing I am going to use for this is my unit circle. So let me find mine. Here she is. Okay, so I need to fill out this table for tangent. Tangent, remember, is y over x. So if I'm going to go to 0, I'm doing y over x. So 0 over 1 is 0. Next is pi over 4. Y over x, if I divide both of these, that's just 1. Pi over 2. Y over x puts a 0 in the denominator, so that would be undefined. So go through your whole unit circle and complete the table. Go ahead and press pause. Wow, welcome back. Let's check our table. -1, 0, 1, undefined, -1, 0. I think that's right. Looks right to me. Okay, so now we're going to graph these. So at 0, 0, pi over 4 is halfway between 0 and pi over 2, so we're going up 1. Now to graph undefined, that is a sister asymptote. So at pi over 2, that's an asymptote. 3 pi over 4 is -1, then 0, then 1, undefined, -1, 0. Cute. Okay, so this is what tangent looks like. Before I graph everything, I'm going to repeat this across the whole graph. Cool, 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 cool. These are all a line apart. Then we have the 0 between each, down on the left, up on the right. If you want to graph this in Desmos with your calculator to see what it looks like, that'd be really fun and cool. But I will show you. It kind of looks like a bunch of cubic functions going across your graph. Say, whoa. I know. And that's tangent. Okay, the general equation for tangent, so parent function, y equals tangent theta. Period for tangent is going to be a little different. The section that's repeated across the whole graph is only a length of pi this time. Domain is not all real numbers because it skips where that asymptote is. So the way we're going to write this is I'll put all real numbers except for x doesn't equal, and I need to state all the places the asymptotes are. Well, I'm not going to sit here and write every asymptote because I would literally be writing for the rest of my life. So I'm going to pick one asymptote. It doesn't matter which one. I'm going to pick pi over 2. Plus or minus, because there's some to the right, some to the left. Okay, and the length they are apart is pi. Yay! Range is all real numbers. It doesn't skip any sections. It goes up and down forever. And then equation of your asymptote. To save time and energy, we can use the same one, but you do not have to. You can pick any asymptote you want. I had that question from the last homework because the asymptote and the domain didn't match, and that's fine as long as you actually pick an asymptote that it skips. And there's tangent. Something about the graph that we're going to see in a second when we have transformations is that this section is your amplitude, up and the down. Cool, cool, cool. Okay, cotangent now is just the reciprocal of tangent. So instead of doing, let's make a note, instead of doing y over x, we are now doing x over y. So still using your unit circle at 0, x over y is now undefined. X over y, this is still 1. X over y, now this is 0. X over y is -1, and keep going. Undefined, 1, 0, -1, undefined. And we're going to plot this just like we did tangent. So at 0, we have an asymptote. At pi over 4, I'm going up 1, pi over 2, 0, 3 pi over 4 down 1, and then an asymptote. So I can see already this looks pretty similar, but cotangent is like a decreasing function where tangent is increasing. It's like a reflection of each other. Keep it going and repeat everything across the whole graph. Yay! Feel free to pause if you need to, if I'm doing things faster than you. So not only is cotangent decreasing where tangent is increasing, but if you notice, we start on 0 with tangent. I'd like to make a note of that. We start on 0 with tangent, but with cotangent, there's an asymptote on 0. So my first point, I would say, is like pi over 2. We'll need to know things like that whenever we're graphing. So there's a phase shift and a reflection basically to get to cotangent. General equation, I'll write the parent, y equals cotangent theta. Period, still like tangent is pi. That's the section that's repeated. Domain, it's everything except where the asymptotes are. So I'll pick the asymptote of 0. Plus or minus k pi. Range is also all real numbers. And then I'll use the same equation for asymptotes that I used in the domain. Cute. Okay. Same as tangent. This is like our sinusoidal where our vertical shift is. And then we go up and down the amplitude. Alrighty. Keep a finger on this page so we can refer to it as I do our transformations. For this first one, I have 2 transformations. I'm going to be going left pi and up 2. So nothing happened to the period. That'll stay pi. I go up 2. Phase shift, I'm going left pi. I'll save everything else for after I graph. So what I like to do here is I know tangent starts on 0. So I'm going to move left pi and up 2. So left pi, up 2. Here's where my graph is going to start. The period is pi, so everything is pi apart. So I'm going to put all the rest of the points pi apart. Between those coordinates is where our asymptote lies. So here, 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 here. This isn't negative, so I am going to be increasing still. And the amplitude is 1. So I'm going to go up 1 and down 1 on each side. Cool. Okay, so my asymptote equation, x equals, pick any asymptote. I'll pick pi over 2 plus or minus k pi. And I'll use that same equation in the domain, but again, you don't have to. And the range is all real numbers. Cool. Let's do a cotangent. So given this equation, there's going to be a reflection. So for cotangent, instead of decreasing, we're going to be increasing. And the amplitude changes to 2. So the period is still pi. There's no vertical shift. There's no phase shift. All right. Cotangent normally starts on pi over 2, right? Let's check that. Yes, there's a point on pi over 2. And I'm not moving anywhere, so I'm going to stay at pi over 2, and the period is pi. So I'll put all those points pi apart with asymptotes between. The only transformation we're doing this time is, again, the reflection and the amplitude. So it'll stretch our graph. So the reflection, instead of cotangent decreasing, we're going to increase. So down on the left, up on the right, and make sure you're going 2. So down 2, up 2. I'm just going to do a few this time, so I'm not making a 20-minute long video, but you can do all of your graph. Cool. Equation of the asymptote, there's one on 0. I'll use that same thing in the domain. And the range is all real numbers. Okay, let's do one with a few more transformations. Number 3 has a b value. That's going to change our period. Our period is normally pi. So instead of 2 pi over b, now it's pi over b. So pi over 1/2 is 2 pi. There's no vertical shift. There is a phase shift to the right, pi over 2. And we'll save everything for after the graph. So tangent starts on 0. Let's do the transformation. So I'm going to go to the right, pi over 2. Every point from here is going to be 2 pi apart. So I'm going to go here and here. Between those points is the asymptote. And now I'm going to increase because it is positive and go up and down the amplitude. The amplitude is 1. So I'm going to go up 1 and down 1 on either side. Yay! Asymptote, there's one at negative pi over 2. Oh, careful. They're not pi apart anymore. They are 2 pi apart. I'll use the same thing for the domain. And range is all real numbers. Questions? Great. Let's do one more together. We'll do this cotangent. Oh, we got a bunch of 2's happening here. Good thing I love 2's. So let me fix my. The amplitude is 2. I'm going to be doing pi over b. So my period is pi over 2. My vertical shift, I go down 2. That wasn't in parentheses, so it's not a phase shift. Okay, so I know cotangent starts on pi over 2. I didn't move left or right, but I did move down 2. And then each one of these points is going to be pi over 2 apart. So boom, boom, boom. I'm not going to do the whole graph on this one. Okay. Between these points gets the asymptote. Oh my gosh, we're crying. We are crying. This is the babyest graph. Oh my gosh. Oh my gosh. And then from here, we're going decreasing right. It's cotangent. So up on the left, down on the right, and make sure you go up and down 2. Oh my gosh. Whoa. Little baby girl. And again, you can draw that across your whole graph if you want to. Okay, equation of the asymptote. So I have to really think about this one. Let's look. Let me wait for this to focus. Okay, so I'm going to choose the one to the left because that's the closest to my y-axis. And that asymptote is halfway between 0 and negative pi over 2. So half of a half is a fourth. So that's at negative pi over 4. Okay, and they're pi over 2 apart. We'll use that for the domain. Again, you don't have to, though. And my range is still all the way up, all the way down forever. Okay, that's tangent and cotangent. Your assignment. I have plenty of practice problems on the next page. When I say plenty, I mean 4. However, your assignment that you're going to see in Schoology is I did number 9 and 10 completely. I took a picture, showed my work. However, I did them wrong on purpose. Your job is going to be to figure out what I did wrong. It's going to be the easiest way it's going to be to do that is for you to do 9 and 10 and then compare your answer to mine. All right, see you later.